Okay, in this lecture video, we're going to look at the Lewis structure of oxoacids, and those are acids that contain oxygen. So acids that have oxygen in their chemical formula. And in these particular types of acids, there's just a little hint for drawing Lewis structures, and that's that you're going to find H's attached to the oxygens. How many H's are on oxygens depends how many there are in the formula, but right now we're going to look at a little trick. So we're going to look at the oxoacid is nitric acid, and it has the chemical formula HNO3. So oftentimes when you have an acid's formula, the H is written in the front as a hint that it's an acid. And then this is an oxoacid because we have some oxygens in this formula. So we know that in our structure, this H here is going to be attached to one of those oxygens. So let's go through our process. We have one hydrogen atom times one valence electron. We have one nitrogen atom times 5 valence electron. And we have 3 oxygen atoms times 6 valence electrons. That's a total of 24 valence electrons to put on our Lewis dot model, and a total of 12 pairs. So then I'll arrange my atoms symmetrically about the central atom, which, oops, I forgot to tell you, is going to be nitrogen. So here's our structure. So when I give this to you, if I were to give this to you on a worksheet or an exam, I would underline that nitrogen for you. So then we know that we're going to put our nitrogen in the middle. We're going to arrange our oxygens symmetrically around it. But since this is an oxoacid, we know that one of our hydrogens is attached to an oxygen. So I'm going to attach it to that oxygen over here. I'm going to connect our oxygens by the single bond to our central atom. So we've used a total of 4 electron pairs so far. So that means we have 12 pairs minus 4 pairs used, 8 pairs of valence electrons left to place on our structure. We know our hydrogen atom is done. So if you play around with this, you'll find that in order to complete the valence shells on the nitrogens and the oxygens, you will need a structure that looks like this. You'll have to use a double bond to the nitrogen. Otherwise, you won't have enough electrons to complete the valence shells on all of the oxygen atoms. So then let's tick off our electron pairs to make sure we have all 12 pairs represented. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then let's count how many electron pairs are available, or how many total valence electrons are available to each atom. So this oxygen has 2, 4, 6, 8. That completes its valence shell. This oxygen has 2, 4, 6, 8 with this double bond, so that completes its valence shell. And this oxygen has 2, 4, 6, 8. And then finally, our nitrogen also has 2, 4, 6, 8. And we already said that our hydrogen, which formed one bond, completes its valence shell with 2 electrons. So all of our atoms now have a completed outer shell. We have our hydrogen attached to an oxygen because this is an oxoacid.